Hello, it's Professor Asma Parveen from Department of Psychology, Aligarh Muslim University. Today I will be talking about sampling. Sampling is a very important process in the research as we all know. It involves selecting a smaller portion of a larger population to gain insights and make inferences about the whole population. It's like examining a small piece of something to gain an understanding of the whole. Researchers often choose to study only a few specific things because they believe that by doing so, they can gather information about the entire population. This selection of items is known as a sample, and the process of choosing them is called sampling design. The survey conducted based on this sample is referred to as a sample survey. The accuracy of the sample is of utmost importance as it needs to effectively represent the characteristics of the entire population. This ensures that the conclusions drawn from the sample are valid and reliable. By carefully selecting the sample, researchers aim to capture the key traits and attributes that exist within the larger population. This allows them to make generalizations and predictions about the whole population based on their findings from the sample. Sample design plays a critical role in ensuring the validity and reliability of the research. Researchers must consider various factors when designing the sample, such as the size, diversity, and representativeness of the chosen items. They need to ensure that the sample is diverse enough to account for different perspectives and variations within the population. Additionally, the sample should be representative, meaning that it accurately reflects the demographic and characteristic makeup of the entire population. But what is the need for sampling? Sampling is commonly used by most of the researchers, and there are various reasons for using sampling. One reason for using sampling is that it is cost effective and time efficient compared to studying the entire population. This means that valuable resources like time and money can be saved. Sampling often leads to more accurate results because the individuals conducting the study are usually trained and experienced in their field. Another situation where sampling becomes necessary is when the population being studied has an infinite number of members, making it impossible to study everyone. Furthermore, sampling is the only option when a test requires the destruction of the item being studied. For example, if a product needs to be tested for quality control, sampling allows for destructive testing without compromising the entire batch. Sampling also enables us to estimate any errors that may occur and provides valuable information about specific characteristics of the population under study. There are certain differences between sampling in quantitative and qualitative research. In quantitative research, the goal is to select an unbiased sample that represents the entire population. This means that the sample should be similar to the rest of the group or completely different. On the other hand, qualitative research considers factors such as ease of access to potential respondents, their extensive knowledge on a specific topic, and how typical or different they are from others. These considerations are not acceptable in quantitative research. The purpose of sampling also differs between quantitative and qualitative research. In quantitative research, the goal is to make inferences about the whole population based on the selected sample. In contrast, qualitative research aims to gain in depth knowledge about a specific situation, event, or individual. The assumption is that the individual is representative of the whole population and can provide insights into it. Another difference between sampling of quantitative and qualitative research is that in quantitative research, the sample size is predetermined based on various considerations. However, in qualitative research, the focus is on gaining detailed knowledge rather than adhering to a specific sample size. Quantitative research places considerable importance on sample size, especially for studies that aim to formulate policies, test associations or relationships, or establish impact assessments. Larger sample sizes ensure that people with diverse backgrounds are included, making the sample representative of the whole population. In qualitative research, the sample size does not play a significant role. The purpose is to study only one or a few cases in order to identify the spread of diversity, not its magnitude. The sample size is determined by reaching the data saturation stage during data collection. Randomization is commonly used in quantitative research to select a sample that represents the study population and avoids bias. However, in qualitative research, there is no attempt to randomly select a sample. Instead, researchers purposely select respondents who have rich information to provide. While most sampling strategies can be used in quantitative studies, including some non probability ones, only non probability sampling designs can be used in qualitative studies. This ensures that the requirements of the research approach are met. Sampling in quantitative research. In quantitative research, sampling is the process of selecting a smaller group called a sample from a larger group known as the sampling population. This method is used to estimate or predict certain characteristics or trends within the larger population. To understand this concept, let's use a simple example. Imagine you want to find out the average age of students in your class. There are two ways to do this. The first method is to contact every student in the class, ask for their ages, and add them all up, and then divide by the total number of students. This gives you the exact mean age of the class. However, this can be time consuming and resource intensive. So, the second method involves selecting a few students from the class, asking for their ages, adding them up, and then dividing the number of students you asked. From this smaller group, you can make an estimate of the average age of the entire class. The same idea applies when trying to determine the average income of families in a city. Instead of going to every family and asking for their income, which would require a lot of effort, you can select a few families as a basis for your inquiry. By gathering information from these selected families, you can estimate the mean income of all families in the city. Opinion polls also use a similar procedure. They are based on questioning a small group of people about their voting preferences. Based on the results from this small group, predictions can be made about the probable outcome of an election. When conducting research, it is important to understand that you cannot study the entire population of people all at once. Instead, you select a smaller group called a sample to represent the whole population. The goal is to gather information about the entire population based on what you find in the sample. Sampling has its own advantages and disadvantages. On one hand, it saves time and resources because studying the entire population would be impractical. However, the downside is that you cannot gather specific information about the population as a whole. Instead, you have to estimate or predict their characteristics based on what you learn from the sample. This means there is a possibility of error in your estimation. Sampling is a trade off between saving time and resources and compromising the accuracy of your findings. It allows you to make an estimate about the overall situation in the population, but it is not a guarantee of complete accuracy. If your sample truly represents the population and your research methods are sound, your findings should be reasonably accurate. However, there is always a chance for error. It is important to consider this possibility of error when selecting a sample. You need to be aware of the limitations and potential inaccuracies that come with sampling. There are certain terminology that we use in sampling, and that are, first one is population versus sample. So when we are conducting a research, it is important to distinguish between a population and a sample. The population refers to the entire group of people that you want to draw conclusions about, while the sample is a specific group of individuals from whom you collect data. The population can be defined based on various factors such as location, age, income, or other characteristics. It can be broad, such as wanting to make inferences about all adults in your country, or narrow, like focusing on customers of a particular company, patients with a specific health condition, or students in a single school. Defining your target population carefully is crucial for the purpose and practicality of your project. Once you have defined your population, you need to select a sample that is representative of that population. A representative sample is one that accurately reflects the characteristics of the population you are studying. This ensures that the findings from your study can be generalized to the larger population. There are different sampling techniques that can be used. Each technique has its own advantages and disadvantages, and the choice of which one to use depends on the specific research questions and resources available. In addition to selecting a representative sample, it is also important to determine the size of the sample. The sample size refers to the number of individuals included in a study. A larger sample size generally leads to more reliable and accurate results as it reduces the impact of random variation. However, a larger sample size also requires more time, resources, and effort to collect and analyze the data. Therefore, researchers must strike a balance between the desired level of precision and the practical constraints of the study. To determine the appropriate sample size, researchers often use statistical calculations or formulas. These calculations take into account factors such as the desired level of confidence, the expected variability in the population, and the margin of error. By using these calculations, researchers can estimate the minimum sample size needed to achieve the desired level of precision. It is important to note that sample size alone does not guarantee the validity of the findings, but it is an important consideration in research design. Second terminology of sampling is sampling frame. A sampling frame is an important concept in research and survey. It is the list or device that researchers use to select a sample from a population. The sampling frame includes all the individuals, households, or institutions that can be sampled. It is crucial for researchers to have a good sampling frame because it determines the accuracy and representativeness of the sample. Obtaining and organizing a sampling frame can be a complex process. In some cases, it is possible to identify and measure every single item in the population, such as in a census or when dealing with the batch of material from a production run. However, in many cases, it is not possible or cost prohibit to reach every member of the population. In these situations, researchers must establish a sampling frame that represents the population of interest. The sampling frame should ideally match the population, but this is rarely the case because populations are usually too large to list all members. There are different types of sampling frames that researchers can use. One type is a list frame, which is a complete list of all the individuals in the population being studied. Another type is a cluster frame, where the population is divided into clusters and a sample is selected from each cluster. A third type is a stratified frame, which involves dividing the population into subgroups based on certain characteristics and then selecting a sample from each subgroup. Each type of sampling frame has its own advantages and disadvantages, and researchers must carefully consider which one is most appropriate for their study. A good sampling frame has certain qualities. It should include all individuals in the target population and exclude those who are not part of the target group. Each member in the frame should have a unique identification and there should be no duplicates. The frame should be organized in a logical manner, such as alphabetical order, and it should be up to date. These qualities ensure that the sample drawn from the sampling frame is representative and accurate. There are several ways to obtain a sampling frame. One way is through existing list or databases such as voter registration list or customer databases. Another way is through phone numbers. Phone numbers are randomly generated and called to gather data. Researchers can also create their own sampling frame by conducting a preliminary survey or using other methods to identify potential participants. Regardless of the method used, it is important for researchers to ensure that the sampling frame is representative of the population and includes everyone who should be included. Maintaining an updated sampling frame is crucial for accurate research. People move, change addresses, or pass away, so it's important to regularly update the sampling frame to reflect these changes. Researchers can use various strategies to keep the sampling frame current, such as conducting follow up surveys or cross referencing with other databases. By ensuring the sampling frame remains up to date, researchers can enhance their validity and reliability of their findings. Next term is sampling design. Sampling design is an important tool that researchers use to study a smaller group of people or things in order to draw conclusions about the larger population. This method allows them to make informed decisions without having to collect data from every single individual or item in the population. By carefully selecting a representative sample, researchers can save time and resources while still obtaining accurate results. Before collecting any data, researchers must determine the sampling design they will use. This decision is crucial because it sets the foundation for the entire study. There are various methods available for sampling, each with its own advantages and disadvantages. These methods have been provided to the researchers with a range of options to choose from based on their specific research objectives. Next term is statistics and parameters. These two terms are very important terms, statistic and parameter. A statistic is a characteristic that describes a sample, while a parameter describes a population. When we calculate measures like mean, median, or mode from a sample, they are called statistics because they describe the characteristics of that specific sample. On the other hand, when these measures describe the characteristics of an entire population, they are referred to as parameters. For instance, the population mean is a parameter while the sample mean is a statistic. The main objective of sampling analysis is to use statistics to estimate parameters. This allows us to make inferences about the whole population based on the information we have gathered from a smaller sample. By understanding the distinction between statistics and parameters, we can better analyze data and draw meaningful conclusions. Next term is sampling error. It is a common occurrence when studying a small group of people instead of the entire population. This can lead to inaccurate data and is known as sampling errors or error variance. These errors are essentially random discrepancies in our assumptions about the entire population based on the sample. Understanding and accounting for these errors is crucial when interpreting the findings of a study. Precision is the other term that is used to describe the range within which the average of a population or another measurement is expected to fall. This range is determined by the level of confidence specified, which can be expressed as a percentage or a specific number. In other words, precision provides a measure of how close the estimated value is to the true value. It helps us understand the reliability and accuracy of our measurements or predictions. For example, if we have a high level of precision, it means that our estimates are likely to be very close to the actual values. On the other hand, a low level of precision indicates that there is more variability in our estimates and they may not be as accurate. Therefore, precision plays a crucial role in various fields such as science, statistics, and research, where accurate measurements and predictions are essential for making informed decisions and drawing valid conclusions. Next term is confidence level and significance level. These are the two important concepts in statistics and research, and they help us understand the reliability and accuracy of statistical research. The confidence level refers to how likely it is that the results of a sample accurately represent the true condition of the entire population. It is like a measure of certainty. For example, if we have a confidence level of 95%, it means that there is a 95 out of 100 chance that the sample results are within a certain range of accuracy. On the other hand, there is a 5 out of 100 chance that the results are not accurate. Precision is another key factor in statistical analysis. It refers to the range within which an answer can vary and still be considered acceptable. So, the confidence level indicates the likelihood that the answer will fall within this range. It is like a measure of how close the answer is to the truth. Significance level is the opposite of the confidence level. It indicates the likelihood that the answer will fall outside of the acceptable range. So, if the confidence level is 95%, then the significance level would be 5%. If the confidence level is 99%, the significance level would be 1%. It's like a measure of how unlikely it is for the answer to be inaccurate. To better understand these concepts, we can visualize them using a normal curve. The area within the precision limits for the specified confidence level represents the acceptance region. This is where the answer is considered accurate. On the other hand, the area outside of this acceptance region in either direction represents the rejection regions. This is where the answer is considered inaccurate. It's like drawing a line between what we can trust and what we cannot. Next term that we use in sampling is sampling distribution. When analyzing samples, we often examine something called a sampling distribution. This distribution is created by taking multiple samples and calculating various statistical measures for each sample, such as the mean or standard deviation. Each sample provides its own value for the statistic being analyzed, and all of these values, along with their frequencies, make up the sampling distribution for that specific statistic. For instance, we can have a sampling distribution for the mean or a sampling distribution for the standard deviation among other statistical measures. It is important to understand that each item in a sampling distribution represents a specific statistic from a sample. If we have a large number of samples, the sampling distribution tends to resemble a normal distribution. This is significant because the mean of a sampling distribution is equivalent to the mean of the entire population. Therefore, we can utilize the mean of the sampling distribution as an estimate for the mean of the population. This is all for today. I will continue this topic in further lectures. Thank you.